one went till 4, so I didn't know if we were off 4 or 5.
Yeah, I know. Yeah. Whenever you're ready.
All right.
You're calling the shots.
I'm calling the shots. Cool. Let's get going. All right, well, I'm Brad Armstrong. Probably met some of you before at GDG. I was an organizer with that group for 3 or 4 years. I work at Code 42 as an engineer, primarily on the Android platform. At my job, I actually don't do much Android app development. I actually, at Code 42, we have kind of a separate service platform that's common to all our operating systems. And so I kind of work on developing that, and then we have other developers that build applications on top of that. So in this talk, I'm going to talk about me getting to play with actually building Android apps, because I have to actually do that on the side, even though I work in Android all day long. So let's go through it. This talk is Where to Drink in Minneapolis. It's a subject near and dear to my heart. If you want to follow me on Twitter, or you do follow me on Twitter, then you know that that's mainly what my feed is about. I might talk about tech sometimes. Plus, Google Event. Felt like I needed to put that there. Wow. We'll see how this resolution works out for me. Okay. Anyway, that says problem. Actually, that's my problem. My problem right now is my screen resolution. You want to help me out? Yeah, thank you. Oh, nice. Cool. Thanks. That's why you got guys like you in here, rocking it. 2 different object partners.
Yep.
They're probably hiring.
Yep.
All right. All right. So I've got a problem. My wife's a big foodie, so a large amount of our free time and disposable income goes into eating at restaurants. I myself have a passion/problem with craft cocktails, so a lot of my disposable income goes into drinking, preferably a good bourbon. And what we find is we keep going to these restaurants, highly rated, these little chef-owned restaurants, and many of them don't have full liquor licenses, so they're beer and wine only. This is a big disappointment to me. My wife loves wine, she doesn't care, so she doesn't know why this is a problem. But I'd like to know before I go if we're going to run into this situation, or if just know if there's a place around me that has a full bar. Many of them don't, so this is my problem. If I have an easy way to figure out who can get me bus bourbon. So back in around November, I was reading about Minneapolis opening up their data with this open data portal. And I've been hearing a lot about open data, like Minibar last year and stuff, and I'm like, well, this is interesting. Things that you used to have to write in a request for something, and then it would take 2 weeks later, and then maybe they send you something. Now they're going to expose, and they said there's going to be developer APIs. I'm like, cool, that sounds like something that's interesting to play with. So I started looking at what kind of stuff we could learn about. So they're like, there were 311 incidents, crime statistics, fire police incidents, open rental licenses, open liquor licenses. Well, that got my attention. So liquor licenses, interesting. What can I do with that? So when I'm like playing with technology and learning about apps, like going to a conference today and you get all excited about some of the things you're hearing, I'll go read about it and stuff, and maybe I'll do a hello world, but that's kind of boring. And I can't learn it unless I can start building something for it. I can't build something unless I have like something to do. I need a problem to solve. So I've had this problem, and now this has sort of piqued my interest. Like, okay, so if I could get liquor licenses, what could I do with that data? So if we just kind of go take a look at their site, opendata.minneapolismn.gov, you can see that they have all these different kind of data sets that are available that you can get into, and it tells you like how many attributes, like how many data points there are, how many fields there are in each one, and how many rows. There's a lot of stuff out there, and it's kind of a very slow site, so I have gone and already pulled one out of the oven here, and this is where you finally find the on-sale liquor licenses, and this is what I was looking for. So I can see that there's all these attributes here, and actually if I open this up, it gives me a better description of what some of these are. So I can see stuff about the permit, decision about it, name of the place, stuff like that, and what kind of looks like maybe some coordinates, so maybe location information that seem reasonable. But I don't see anything yet about an API. It's just data, and they're like, hey, you can download it, and we'll give you an Excel spreadsheet or something like that. That's not going to cut it. So I got this thing called source here. That looks interesting. So I guess if we just, let's take a look at that is. That still looks like something that doesn't tell me anything, but what's interesting here, by the way, if you go to this API reference, which is the first thing I did, and I think anyone would, they're like, oh, cool, this is where I learned about this. This goes to this thing. Looks like, I don't know what that is at all, but it's not what I want, so I just forget that. But there's this thing called query down here that I started playing with. So this seems like something I could do. I'm like, well, let's just get everything. There's like a get, and well, that didn't work. That's supposed to not work. It's okay. All right. There's a where clause. Anytime you want to like hack sites or something, the first thing you do in your query string is put 1 = 1 or something and just see what happens, right? And then after that, you say drop table users. Pro tip. Okay, let's see if this. Okay, all right. Well, I got something, just not anything useful. That's fine. So anyway, what I started figuring out was like, okay, this is just a SQL form, right? And something weird is that it's got this thing called out fields here. It's not a band. It is a label. Anyway, I'm like, well, star. How about all of them? That seems cool. And then it's a little more interesting if we get rid of that, JSON. Now we're talking. So now, well, this looks like the fields, so that's not too interesting. But here, all of a sudden, I start recognizing restaurant names. And Wild Rose Cafe, and I'm like, not only is there restaurant names, but they're like right next to my work. And then the first one's listed, it's like, is this for me? But anyway, it's like, okay, cool. There's this thing called features, and it's got attributes, and each attribute looks like it's a license, a liquor license, and it's got some stuff, and it says when it was issued, and it kind of has this thing that looks like it would tell me what the license type is, so that's cool. And it's got this that looks like lat long. Cool. So, all right, now I've found a data source, which is kind of the most important thing when you're building an app. So I think this might work, and if I just use this URL, maybe this is my API, I can just plug it in and see what happens. Okay. So now we got a data source. Let's stop there for now and see where else we can go. All right. So now I got a little solution going. I got this data, and here's like some of the fields I'm going to be interested in. And this is what those things look like. That's good enough. All right, we're done with this. No, we're on this one. So like I said, I don't get to play with a lot of this technology we're talking about at my job, so I have to do it at night while my wife is eating and I'm drinking. That's what we're talking about. So here I got a chance to play with something I never get to do, and that's Google Maps. So this is the app I want to build. I want to take this data somehow, I'm going to use those locations, and I'm going to plot some pins, and somehow I'm going to show, does this thing have a full license or not? That's what I'm thinking about. And very fitting to today, there's a couple libraries that been waiting for a reason to use, and that's Retrofit and RxAndroid. And we talked about those in previous sessions today, you may or may not have been in, so hopefully give you something that is just another way to say it, that maybe it sticks with you. And we'll show it maybe in a larger, show a full application. Finally, a sample that does something useful. That's my goal today. All right. So this is our plan. Done. Okay. To do that, I got to start with the end in mind, right? Someone said that begin with the end in mind. The end of my app is a map. So let's talk about the Google Maps API for a second. Maybe for a lot of people, they're like, well, it's the first thing I played with. Well, it wasn't the first thing I played with. So to me, I'm like, okay, I got to go learn a little bit about this. It's pretty easy to find out about it if you just type Map API in Google or Android. It, is easily the first thing that comes up. Looks something like this. And all I wanted to do was very quickly figure out how can I get a map application built and how can I put a markup in. I'm just laser focused on just a couple little things I need to make this simple app. Because I'm not trying to build an app to sell, I'm trying to find a place to drink. So this goes through what you need to do to make an app. We'll cover it a little bit, just a map app, just so you have some sense of it. It looks like it's pretty easy. I get some activity and I get a map fragment and then I have a map. When the map's ready, I can do things, I can add a marker. Bang, that's what I need to do right there, add a marker. So it says here, let's get started. What do I gotta do to make this happen? And it gives you all these things to do. You go configure Google Play Services, you go make an API key. If you guys have ever had to consume Google things before, you know you have to go to this developer console, you make an API key for your app somehow. There's ones for different apps, blah, blah, blah. Yeah, it sounds like a lot of work. All right, let me shortcut this for you because there's a way easier way to do that. But this does have one thing I want in there, and that's drawing on the map because that's what I want to do, and a thing called markers. That seems like it's going to get me there, and that's code I want right there. So that's our goal, doing something like that, a position and a title. That's all I need. And actually, Android Studio makes this pretty easy for you. They have just a wizard when you're building a new project. And usually people pick like the first, I don't know, I want activity or I want the activity with side pane and stuff. But there's this other one that you're not paying attention to. It's over on this side and it's called Maps Activity. And when you do that, and I just built one here just to give you the demo out of the box, like what does it give you? So first of all, it sets up Gradle for you and sets you up with Google Play Services. That's fine. You don't care what the code looks like. It's not important. It does it for you. Who cares what it says? But it makes the map work. And what I really just want to show here is it actually sets up these two resource files for you. These Google Maps API to XML, and it does one for debug and one for release. And that's because you have one API code for your test apps, and when you want to go to the Google Play Store, you need to give it a different one. So if we just look at this, all right, we'll make this bigger. It actually, in there, just tells you exactly what to do, how to make your API. It's like, basically, take that link, go to it, take that crazy value and paste that into the place that I just took you, and then take that API key that website gives you and put it there, and then you're done. So it really, now you have a map app. It's crazy. So there you go. Hopefully we learned something today. Thanks for coming. Building maps. And then you can see it gives you, well, let's see if I can show it here. Source, main. The other main thing you're going to get is this maps activity. Pretty simple. And on create, which is going to call setup map if needed. And in this thing, you get some reference to a map. And if you have the reference, it calls setup map. And in setup map, add marker. Create a new marker option. And this one by default puts the marker at 0, 0, which is the middle of Africa. It's a start. We got to just dial that in a little bit. We're trying to get some progress. Okay, cool. This is looking good. Got something going. So we started with the end. This is what we're trying to achieve. We know we got to make one of these marker options. We've got a data source. So all I need to figure out now is how to get that data into that marker, and we're good. So you guys know apps. Well, okay, you guys know because you probably build mobile apps. None of your friends or anything understand this because they have an idea for an app, and it's something like, yeah, it's cool, man. It's like it's going to find where all the bikes are, and then it's going to show you them, and then if they have a price, it'll show it. You can just call the guy and ask him if he can buy his bike. I'm like, cool, man. Where do you get that information? It's on the phone. It's on the phone. He's got to build an app. Okay, your apps are all about the data, and the key to having an app is finding a good data source. So we've got one. Let's go back and just investigate it a little bit more, what we've got. All right, so we got this data here. We can see what we have for a license. I don't know that much about it yet. So let's actually just go to like the query and see if we can, figure out what we're talking about. I just want to go back. So somehow we have this set of data where we can ask it for something, for a set of fields with some geometry that I don't understand yet. But if I say 1 equals 1 and I put together that thing, I can ask for it in JSON, GeoJSON, or HTML. We decided to do GeoJSON. We got something good. We got these coordinates. I would have called them lat long if it was me, but maybe there's something else. Because it says it's something called a WebGS Web Mercator Auxiliary Sphere. So that's a fancy name for something, but I don't know what it is. And it turns out that if I take this data, well, that's what we do with our maps app. This is what we're trying to do, profit. And shoot, I should have made that drink. All right, here's the data we're looking at. This is the stuff we care about. I kind of highlighted the few fields I think we're going to use, like this name and address and the location. And I want to do this, we establish that. Okay, here's the position we care about. And so what I did is I first just plugged this in, like I just went to the URL, Google Maps, and you can actually just, through the URL, you can plug in lat long and it'll just plot that for you on the web. Okay, it put me, I don't know where I was in the middle of some ocean, really far away. Like that is not lat long. So now I had to go back and go, okay, this WGS auxiliary sphere, what is that? So we're gonna have to talk about GIS for a second. Does anyone know this says geographic information systems? Is there people that know a little bit about that? Maybe? I'm glad you're here. I'm gonna need some help. Because this is it's like this crazy world. It's really big. Had no idea it exists. There's it's pretty cool. So but that's like a whole talk, and none of the people that came here would have come if I would have said, hey, learn about GIS. So it's my hobby. All right, so here's what we need to know. There's this big platform called ArcGIS. It's like the biggest player in the world. It's like it's what governments put their data on. It's what Minneapolis Open Data Portal built their stuff on. It's like when police departments want to do heat maps of crime or something, they push all this data to this ArcGIS system, and it knows how to layer data sets on top of maps. So you have a map with just an area, and you can have all these different layers that specify different information about data. I don't know. So it's like where people live, plus where crime happens, plus where those bikes are for sale. And you put it all together, and now you have your bike app, stolen bike app, I guess. So anyway, this is developed by this place. They have this hostess product. This is a big deal. All right, ArcGIS, and if we look at the URL, bam. Okay, so that makes sense. So we went to ArcGIS to get this data. That's actually where we're getting all our data from. All right. Now there's these things called geodetic datums. Geodetic. I just call them datums. There's datums. Okay, so what's a datum? Everyone knows Earth is round, it's a sphere. That's exactly what the pictures look like when I see them. And the truth is that Earth is actually a little flatter at the pole, so it's a ellipsoid, something like that. But how flat is it? We're not sure. It actually isn't. The equator isn't always actually at the total center this way, and it bulges in some places, and it's different. I had no idea. And so different people have different ways of describing what the size of Earth is, the sphere, and all these things, because it turns out, depending on how you measure it, when you want to plot a point on it, if you don't know how far around it is, your point is in the wrong spot. So these datums are an agreed to standard that says, when we're using this datum, we're saying this is the shape of the Earth, and these are all these distances, this is how big this stuff is. Okay. Now, most of our maps are flat. We see it in the 2D space. So how do you push a sphere onto a map? Imagine you are peeling an orange, also not a perfect sphere, it turns out. And you've got to take that peel and you got to just like push it down onto a piece of paper, and you can see that, I mean, it's not going to stay attached. It's all going to be spread out and it's going to be weird, but you've got to have a way to put all that back together. And for those, they have a name of that. It's called a projection. So projections attempt to display a three-dimensional object in a 2D space. Okay. Datum's projections. What are those? Why do we care? So we have these things called coordinate systems. There's geographic, they're 3D, there's projected, there's 2D. That's what the name of these things are. There's a thing called WGS84. Sounds familiar. And turns out this is the World Geodetic System, coordinate system. It is the 3D GSCS? Anyway, it's what's used by GPS. You know, it's used for the traditional lat long. We're doing that kind of stuff. We're actually using WGS84. That's what it's doing. Okay, then there's this 2D projection called Web Mercator. That thing is that is the projection with all its rules that will say, here's how you take a 3D space in WGS with the WGS84 datum and project it onto a 2D space. Cool. Those are the words that look like we saw in our coordinates. They had words that looked like that. And finding those words, it takes so many Google search tabs. It's crazy. All right, so I'm like, okay, these coordinates are good. I'm trying to put these into Google. Google's a flat map. That means it must need these. It must want 2D coordinates. No, Google wants 3D coordinates because all the websites say, hey, Google is a web mercator. That's what it's using. I'm like, sweet, then these coordinates should work. But they don't. But what they don't tell you is like, yeah, it's web mercator, but what its input, to be nice to you, is that we're going to take WGS84 as input. You can give us real lat long. We'll worry about all the projection translations, and we'll put it onto this flat map for you. But like I said, it doesn't tell you that. So you just keep hitting enter, and you still end up in the middle of the ocean with these coordinates. But then there you find out what's going on. You're like, and people say, well, I'm like, okay, well that's great. I need to do this in my app. I need to take those coordinates. I need to turn them back into lat long to get them to Google to turn them back into the things they should be. And they're like, great, just download the software package. It's called this, and it's like only like a couple $1,000s because professionals use it. Like, well, that's not gonna work. I guess I could like put up a Google Tater and install it there and like make a web service call to it. But instead, you finally search around long enough, enough bottles of booze, and you find a formula in math. And it uses pi, so it's super cool. And so it's good. We got it. We did it. All right. Let's make the app. Now I got data. I got some way of getting this data. Well, I know how to translate it. I know what I want to do with it. Now I just got to call a service, and I just got to get it. And I want this to be as simple as possible. Remember, I don't care about building an app. I'm not trying to sell it. I just want to find a place to drink. So, Retrofit, people have talked about it. You've probably seen the thing. It says it's a type-safe recipe. Oh, what is that? Okay, so what does that really mean? All it means is I can describe, here's what you need to know. You need to know the URL you want to hit, and you need to know what the JSON response looks like. Let's just assume it's JSON. It could be XML, it could be protocol buffers. Retrofit supports those. You don't use those. Me and Phil use those. No one else knows what those are. And if you know those things, it does magical things for you. So in this case, let's just pretend I have users.com. They have a massive legal team which allows them to just give all users data for free. So this is what the URL looks like, and I can just create this service interface, and you annotate it like that, and I can call get users, and I'm return to user. This is the promise that the documentation tells me. This is what they tell you. That sounds cool. Sometime later, I have a user activity, and I can get my service, and I can say service get users, and I just get a list of users, and it looks like I'm just calling a method. And this is what's so cool about Retrofit. It just does that. All you gotta do is put it in a jar, and magic happens. A couple other things. But this is what works great for demos. All right, let's go into those couple other things a little bit more. So, Colin just showed this, Dan just showed this, but you never just have to call a URL, and the URL is the same every time. Usually you have, in this example, I've got another service interface that instead of just users, I want a user, and it's got a URL that says, oh, cool, if you just stack ID on the end, I will return you just one user. So I can model that with this user ID token. I pass in a parameter and I annotate it and say, put this token into the path. Substitute the path where I put user ID, and it will do that, and it will make that call. And again, it will tell you that it will return you a user. I don't know how that works yet. It's magic, but we'll talk about the magic. The other thing you can do is you need to sometimes stick stuff in the query parameters. Let's just pretend I only want, this time I want all the users again, but there's a lot of users in the world, and so let's just get the first 100 and see if we get lucky.
Brett,
Yep.
it's probably worth mentioning this is an interface,
Yep.
which means you're not providing implementation.
Not yet.
And so the key here is that Retrofit's providing the implementation.
You're stealing my thunder.
Sorry, man.
It's the next slide. It's the next slide.
Sorry.
Okay. Yeah, exactly. This is not an interface. I haven't had to code anything. I'm just describing what I want to happen. I want it to call this URL. I want it to stick whatever I put that onto that query string. I want, give me that user back. That's all I want. All right. That's okay. It's easy. Now where am I? Well, now this one's useless. All right. No. All right. So we've shown this before. Where did I get this service from? The other slide, I just said, hey, it gets a service. Hey, and then you call it. All right. Somewhere in another class, this is up to you. You're a programmer. You can figure it out. You need to build it. By the way, building this is expensive. Don't build it on every time you want to make the call. Build it somewhere, store it as a singleton, that kind of thing. So in the most simple example, I can give it an endpoint. You saw my URLs and my interface were just the relative paths of the service. In this case, you just give it finally where is this service that you want to go. This lets you call different versions of it, users.com. badusers.com, whatever, maybe they're all the same, maybe one's staging testusers.com, who knows what. All right, and then you call adapter create, you say I want to create this thing, and I defined this interface user service class, so use that interface and explode it and turn it into a real thing, and the magic happens. It's cool. Then you get it for real. Still, how did I get a user out of this? I don't know. Okay, there's other things you can do with this. You can set like logging levels. You can control. You can control the thread pool that this thing has behind the scenes. There's like servlet interceptors, request interceptors you can put in there. This is used like when you have to do secure contexts, that sort of thing. The other thing you do is insert custom type converters. And type converters, it turns out, is how we get that user. So let's just take a look at that for a second. Type conversion, I think Dan touched on it. And basically, by default, it's going to use the JSON library. If you have it available on your class path, it's just going to grab that. It's going to say, oh, this is a JSON request. I'm going to use JSON to turn that data into an object. And usually what it does is says, I'm just going to look for every field in this JSON thing, and I'm going to look at your object, and if it's got the same field, the same name, I'm just going to put that data right there. So that's what's supposed to happen. Rarely do you have a class that models it exactly. A lot of times you're trying to fit something that exists over here and doesn't exist over here and trying to get it to work. So even in this simple case, I've already broken the rules because I want like user ID and this thing has a UID, and I want to use Java naming. This is undercase. Okay. So, but this is such a common problem that they give you this really easy answer, and you can annotate the fields and say, nope. When you find UID, stick it here. Pretty simple. All right, so we're going to look at some more complexity around building these models when we get to the code, because I find the JSON documentation really
It's pretty bad.
All right, yeah, it's pretty bad. Here's the thing, everyone on Stack, yeah.
One question about, I use JSON a lot, but one thing I'm curious about, you do like the serialization
Yeah.
method there. Is it actually calling given setters on the user, or is it just put it right
Nope,
to the public?
you can do it, actually it can be public, it can be private. I don't have, one thing I want to show here is I actually don't have setters. So it's doing like reflection, just sticking it right, it's setting the field directly.
So
I think I,
would JSON use a setter if it was there, or would it bypass it?
no, I don't think they annotate, you can't annotate the setters. You just annotate the fields. You can still have a setter because maybe your code overwrites it if it's a mutable class or something like that.
Has anyone here, I was just curious, has anyone ever used Realm? Is that the
I've heard of it, I have not
Just
used
play
it.
with.
I used it for a project and I used JSON, and I was trying to like you have to create like realm objects that have givers and setters, and they're basically dummy objects, because they don't fill up until like.
Because is that using ORM to do
Yeah.
mapping of the
So I
database? You're
wanted
trying to
to
use the
use-
same one?
I tried to do the same one, I couldn't do it
Yeah.
because it wasn't.
Competing annotations. A lot of times when I do something like that, what I've seen is you've got like entity classes, which are the ones from the database, and I've got these model classes that are more like, you know, the wire in the front end, and usually I only use the entity classes when I want to populate the database. I don't let those flow through the app because I want to have some other way. That's how I've handled that separation before. There's another annotation you can use for Android specifically, parcelable. And it says, well, you know, because serialization is slow on Android compared to this, the parcelable interface or mechanism they have. It's what you use to make so that data can cross between process boundaries, so it's IPC. And so that's supposed to be faster. It's got extra boilerplate from, you know, I guess if you are doing something crazy, you got a lot of these, you probably want to switch over to that, but no need to show it here. Okay. So something more important that we can do, that, and I don't think we talked about today yet, is that Retrofit also lets you do asynchronous requests, because oftentimes I don't want to just make a call and then wait for there. Maybe I've got to spin through 100 of these users, and for whatever reason it's a terrible API, I got to call them one at a time. I don't really want to wait for that request to get done, or when the first one comes back, I maybe not do the call out to get their bookmark information or some information about them. So asynchronous requests allow you to do that. And like we've talked about before, you start to get into callback hell, because what you'll see is what we do is now our interface takes a callback, and it doesn't return anything anymore. It just says you call get user, you give it that callback, and when the response is complete, your callback is invoked. So what does the callback look like? Callback is pretty simple. You only have two things. If it's successful, you get a user, you win. If it's a failure, you get a retrofit error. And you can either do stuff or you can throw stuff. That's how I think about it. So callbacks are good. But in any kind of production-sized app where you're doing this a lot, you know, you start nesting these things. If you've ever used listable features in Guava or something, this gets ugly in a hurry. So Retrofit also has something that's much better that we've also talked about today. That's observable requests. And these are given to you, these are made available actually because of, it's going to use RxJava underneath the hood. Again, if RxJava is made available to it, we'll show how to do that later, it's pretty easy. So with the observable request, now we're back to having something that looks like we can just call get and it comes back and it's synchronous, and it may be or may not be that RxJava hides that from you. We don't care. We just get an observable, kind of looks the same, but now I still call my service get user, and I get some observable user back. I don't get user. Okay, what the heck's that? How many were in just in common session? Okay. Where were the rest of you guys?
It was a great session.
It was great. Okay, so some of these slides will look familiar. I'll try to just breeze over them. But anyway, we're talking about reactive programming here. RxJava is the Java variant of a whole reactive, I don't know, there's a whole bunch of language bindings that allow you to do this reactive style programming. It's somewhat of a functional variant. But one of the ways that people think about it is that if you had been thinking about synchronously, I just make a call to get data, I get something T that's data, or I want to get many of them and I get an iterable or something, a list. The synchronous world we're used to is that I ask for get data and I get a future, and sometime later that's kind of will receive that data. With observable, it's kind of like when you want to get multiple features back. Another way that we think about it is that, I don't know if I have a, no I don't, okay. Another way that people think about it is that with an iterable, that's like a pull model. I'm like saying get data and you say, if has next, get it, get it, get it, get it. Observables turns that around. It's a push model. The observable will tell you when there's something available. You're just sitting there subscribing to it, and it's just telling you about it. Okay, so that's effectively the difference. So that's what observables are. We've got the other side, which is the observer. It's often called the subscriber. And when we put these two things together, this is what's often known as the reactor pattern. It's also kind of, it's basically the observer pattern with this extra goodness of, in the observer pattern, you were just told when there's things available for you. Your observer is, things are pushed to the observer, that's the same. But you have no idea when you should be done observing, and you have no idea when errors occur. So that's the extra layer that gets added here for you. All right. This is what a subscriber looks like. Subscribers are very simple. They have 3 functions that get called back that correspond to exactly what I just said. On next, when something happens, when things are omitted from the observable. On completed, when it's done. On error, if an error occurs. The guarantee is that any observable will at least give you an on-complete or an on-error. So it's guaranteed to terminate at some point, someday. In general, just as a general practice, the observable is usually where we do all the work. Subscribers are usually lightweight. You'll see what we do is take observable and we transform that data to whatever that subscriber needs at the end. And then the subscriber gets it. Technically, usually the subscriber doesn't do a lot of the work. And the reason for that is because with RxJava, what it's also able to do is hide a bunch of the threading model from you. So we'll see an example of that, but you want as much to happen as you can in the observable layer. Subscriber just gets it at the very end. It's a lot like async task is, where you have on post execute happens on the main thread, and you have do background. Do background's observable. Post execute is subscriber. Familiar with that? That's one way to think about it. Okay. Oh shoot, I need that one. Let's take a super simple example. All right, so you can create an observable, and this one's going to just emit 2 strings. It's going to emit hello, and then it's going to emit Cleveland, not world, Cleveland. And then you subscribe to it with my subscriber, the same one we just looked at, which on his or hers, on next, it just said print to the persistent printout. All right, and what the output would be 2 lines, hello and Cleveland. All right, so that's very simple, just to show you that these observables are emitting things one at a time and calling your on next. Okay, it's called it for hello, called it for Cleveland. All right, so where things get a lot more interesting is with reactive operators. This is where we normally would have had to nest callbacks to do many things, like, okay, I got that information back, now when I get that, I want to go make this web service call, or I want to turn that information into this, or I want to listen to, I just want to take the first many of these and do some, and continue on. So here's a bunch of the operators that you have. You have things like group by, which Colin can totally explain to us, and map and flat map. Filtering, I'll take the first 10, I'll skip the first 10, take the rest. Merge and zip are super cool ways to go out to multiple services at once and bring those things back together, and when all have completed, I get one observable, and the rest of my code just doesn't even know about that. It just thinks all that stuff might as well in one service. Could have been 1, could have been 5. That's exactly why that's what Netflix does, because they go out and they say, okay, get a person's videos and get their this and get their favorites, and they make many network calls and they bring all that stuff together. They use zip a lot. So anyway, here's all the stuff you do. Here's an example. So when you start looking at reactive operators and patterns, you're going to see these like stream diagrams or marble diagrams you can see as well. So this is just to show you what's happening. This is a stream that's got some value 0 to value 17. That's the observable. That's what it's emitting. Now let's pretend I said, okay, I'll take that and I'll skip the first 10. So now I have an observable that will emit 10 on. Or skip the first 10, sorry. And then I take that observable and I say, okay, give me the first 5. Now I have another observable that just has the first 5 of that. From that observable, I want to map it and say, hey, to each one of those, tack this on the end, and that's what you get. So one thing that's important to note is that in each of these observables is its own stream. By skipping the first 10, I haven't affected that first stream. That still goes on and could go on to someone else and be the complete stream. I said skip 10, I got a new observable that has 10 and then on from that stream. I have a new stream. So that's very functional. All the observable streams are immutable, and there's copies. So that's the thing that when people are talking about functional programming, it's great for multi-threading because everything's immutable. It can really kill you on performance because you don't realize how much copying is going on under the scenes. So there's a trade-off to this stuff. Anyway. I want to look at map and flat map, two operators, because they're the ones we use often, and we use them in the app. Okay, these are the marble diagrams we talked about. This says I have a stream of 1, 2, and 3. That's what's going to emit it. I'm going to emit 1, I'm going to emit 2, I'm going to emit 3. And for each one of those, it's going to go through this mapping function that says just multiply by 10. So the next observable that I get out is going to be is a stream that looks like 10, 20, 30. The guy that gets this doesn't know how that observable stream happened. Doesn't know this mapping function. He thinks he's got 10, 20, 30. Fine. Now I can add to that. Now this is a new observable stream. Something else can happen to that. That's how these operators get chained together. And this is how you actually have a lot of reusable code, because this could be a really complicated function, and that you might want to share amongst many things, and you can apply to different observable streams. And you can probably just unit test that on its own, which is a really nice thing about functional programming too, is these functions can be tested. So that's map. Map's easy to understand. Flat map is, oh man, flat map. We've all been trying to explain flat map today, and I haven't talked. Okay, I'll tell you what it is, and then I'll just tell you how to figure out what it is. All right, so this is the example. This is off the documentation, which says I've got a function that's going to take a sphere, a real sphere, not a sphere like the world. We know that's not a sphere, don't we? This is a real sphere. And I'm going to emit, for every one of those, I'm going to emit 2 diamonds. So sphere comes in, 2 diamonds. Sphere comes in, 2. That's kind of weird.
Yeah.
Okay. What this wants to show you is that because flat map actually will take each of these and could take this function and push it off to a thread pool for processing. So there's no guarantee that when these things come back that they're going to come back ordered. So it can interleave. There are operators that guarantee ordering, I think cat maybe. So anyway, that's just what it's trying to show, that doesn't guarantee ordering. So okay, one way to think about flat map in this case is that map for every item you put in, it emits another item. Flat map can emit multiple, one to many. It's also emitting it's emitting an observable that has this stream in it. And if each of these is an observable that had their own list, this would not be a list. This is just one item in the list. This is one item in the list. So it takes 3 lists, emits them as a single list with all the items from those lists. That's another thing.
The one that guarantees ordering is concat map.
Concat map, yep. So another way to think about this, here's an example. I've got this observable. Now this time it's got 2 lists, all right? 2 things that it's going to emit. It's going to emit ABC. It's going to emit 1, 2, 3. If I had a map that said don't do anything, just pass this through, I mean, or if just ABC 1, 2, 3, 2 lines, that's all I get. If I did flat map output, it would take those and emit each of those as its items. And it might background that function. I mean, these could get out of order even. All right, that's flat map. Here's the other way I think about learning map and flat map. Put map, and then see if it does what you want. If it doesn't, put flat map, and then it will. Seriously, if you do this enough times, you're like, oh, okay. Eventually, you'll just put flat map, and then you're like, I wonder if just map would work. And then you go to map, you're like, breaks, you're like, nope, flat map. So, all right, so a little bit, just a bit larger example to give you an idea how these things can be put together. Let's assume we have an observable that says it emits, I have this function that says it emits a thing called city weather. Now there's nowhere I can go that gives me city weather. I gotta collect this and put it together. So I return this city directory, something I have with get US capitals, which returns me a bunch of cities. And to that, it's gonna give me a list. I wanna get that into an observable. So I'm gonna flat map that list of cities, and it makes an observable from each one. And then now I have a stream, observable stream of cities. Now, since I have an observable, I can apply this filter to it that just says, okay, now for each of these, if the population is over 500,000, let it go down the stream. So now I've got another observable stream that has just cities, population over 500,000. And finally, for each of those, I go out to this weather service and I get the current weather. And now, RxJava magically might be parallelizing that for me. This is all in the background. It's cool. I might have to make multiple calls and as each one comes back, that one can actually start going on to the next processing, right? This whole, it doesn't have to block and wait for me to get all these cities before it gets done. So it's really powerful. It's going to return that observable. Now actually, there's this thing called cold and hot observables. Don't worry about it. In general, I could create this whole thing, create that observable, return it. It does not get executed until someone subscribes to it, and then it's go. So you can kind of build all these things up. It's not like I returned this and it executed this. I can return this to multiple people, and not until they subscribe to it usually anything happen.
Yeah, Brad, it won't go parallel unless you subscribe to a unless you subscribe on a
On
scheduler.
a background schedule. Yeah.
That's right.
Wait, that first flat map, so is get US capitals a list of lists? Like now I'm confused.
Okay, get US capitals was probably just like a list.
Okay.
Like just regular list. That was some API.
So why don't you just call map like that? This is just a normal list.
Because I want to turn that list into observable. If I just gave it a list to a map, the one thing it would emit would be the whole list.
Okay.
And if you wanted things to iterate for you, this is where and then I'd have to go into some function that iterated for me. So I don't want that. I want actually just each item. So the flat map really, you can think about it, it will iterate through the things for you and emit them to the next thing. So it's like a for loop in another way.
Yeah. I'm thinking of map in like the JavaScript array map, which is more like flat map, I think.
Well, in JavaScript map. That I don't know.
Never mind. Go on.
We're rocking. Okay, let's bring it all together. Let's look at the app. Because I'm getting thirsty. Other speakers had bottles of water up here. They're all gone. I was going to get one. Oh, man. Okay. I literally am getting thirsty. Okay. Let's start here. Let's see if we can put this in presentation mode and see things. All right, this is just to say that where you start is by adding these things to your Gradle properties. And I have not purposely done it the way that Daniel Liu really would have hated. And this is horrible. But I have pluses. I got pluses at the end here. Okay, so anytime like, okay, HTTP gets upgraded, it might be at 2.3 now, it would just automatically get it on the next build and things could break. That's bad. What's funny is that if you go to their site and it just says, hey, paste this in here, it works. This is what they give you. It's kind of like when we all learned how to do async tasks and they all just had their code examples the wrong way, and then like, you know, Diana yells at us on Stack Overflow that we're doing it wrong. I'm like, well, it just told me. So, okay, let's look at the important parts. What's important? Let's talk about what I want to do. Okay, I want, again, let's go back. I want licenses. I want to put those licenses on the marker, or want to make marker options out of them. So I made that. I made a license service. Start there. All right. This is Retrofit in action. That's that big, huge URL that I just took right out of the browser. Like, this worked. Will it work again for me? And it did. Cool. Put it in there. I don't care. Gets me what I wanted. It gets me a license response. With Retrofit, when it's doing observable, the first thing you get is the full response. You can't get a list of things from it, no matter how hard I try. How many bottles of bourbon I threw at that problem. I finally went and just downloaded the code and looked at how it worked, and like, oh, it's impossible. So you get one thing, it emits one thing license response. That's not good enough for me. I want to abstract the normal code from that. I don't even want it to know that this is how it works. So what I did is, in front of this, I put a real service that my code's going to use. So I said, all right, let's make something called a license service. And my license service, this is what I want. I want a thing that returns an observable of licenses. That's what I want to emit. Things are licenses. So you can see here, this is where the magic of Retrofit happened. I created that REST adapter. Here's my base URL for real, the thing we went to. It doesn't have to be just a host thing. You can give it any, anyway, partial paths, that's fine. It's just going to take that path, and it's going to take those other relative paths that I specify in my interface, you'll put it together, it's going to make a call. Nothing magical. So now what did I have to do? Because I know that I call get on sale liquor licenses. That other thing gives me a license response. That's not what I want. What do I want? I want from that, it turns out I want to get the features from that API, and we'll look at that in a second, and turn that into a list of observable features. And then for each one of those, I want to just grab the license out of it. And that's what I want to emit. So real quickly, if you remember, this thing had a thing called features. And each of those had a field called attributes, and that was the license. Okay? So, how did, is that it? Don't need that one anymore. All right. So what I want to show you for a second, really quick, is here's the models I created. I've got that license response that's going to represent that whole response. And all I did was say, okay, that's got a field called features. That's impossible to read, but let's not go back and forth for now. That's just the name of that field. So the JSON is going to find that features field, and it's just going to stick it in there. And that thing was an array, this JSON array. And so it'll put it into a list for you, a list of feature. So then I got a thing called feature. And a feature has a thing called a license, but its name on the JSON field is attributes. That's what this says. It's really blurry. It says attributes. So I use that serialized name thing. So now JSON is going to put that whole thing together and eventually give me this API response that has dot features. And when if we go back to where we were, dot features gives me a feature. It's going to give me observable features. If you remember, each of those features, I was able to get the license off of it.
Brad, if you go up to the top in the view menu, you can actually show the project thing to the left while you have this presentation mode up.
Oh, really? Okay.
Oh, yeah, that'll make it quicker.
So anyway, now I've got a thing of licenses that I'm emitting. That's all I need. I just want to be able to call this thing. So now all we care about is our map activity. Let's pull it together. This looks just like the default template we had, except here on create, I created my license service. You don't necessarily want to do this on every onCreate, because remember, onCreate is going to create an instance of this, that's going to create an instance of the retrofit thing, and that's actually an expensive operation, but for purposes of demos. I actually have another example I can show that, get rid of that. What I care about here is my setup map. Now, if you remember, if you did this out of the box and you took that map activity demo that I put together and you ran it, you'd get a map of the world and a pin at 0, 0, Africa, maybe. I want, when my app comes up, I just want to focus on Minneapolis. I don't have data for Minneapolis, so like, let's just put it on Minneapolis. So how did I do that? Well, there's this like move camera thing where you can set where the camera is going to show on the map and at what zoom level. And how do you find out where Minneapolis is? You Google it and you find some coordinates. And you know what? They're in lat long. And then how do you find the zoom level? You just like keep trying things. You're like 11. So, all right. So here's some now things that you've seen in other things. This is what. So now I've got this license service that will give me all the licenses. But really, what I actually want. What this guy wants to do is he wants to set up marker options that he can plot on the map. And I might as well like build those up on the background thread. I mean, why like build any of those objects like, you know, on the main thread? So I'm going to continue with my observable and continue transforming it here into the marker options that I want here. So now I'm going to, one is I'm going to say I want to observe on the main thread. That's when things come back to me, execute on the main thread. It doesn't, actually this observe subscribe on, as far as I know, ordering doesn't matter. I want to map on, is that going to flip it around? Is that going to?
No. Ordering matters for subscribe on but not observe on.
Okay.
So subscribe on everything before it gets subscribed on those threads. Observe on only affects the subscribe method, so it doesn't matter in order.
Cool. So in my map here, I'm just going to take, by the way, this is all really like verbose code, and if you've used Android Studio, it like sucks these things down into little lambdas for you, but that's not how if you put mouse over it, that's why it's kind of flipping. That's what it really looks like. But anyway, I can take that license and I can take a marker. I can make a marker out of it, and in my license code, I have a little thing that figures out if it's a full license. We can show that. But what I figured out was that license type that we looked at. some of the words mean it's full license, and there's some other words that means it's not. And I figured out the words that it means it's not, and I said, okay, that's all I need to know. So I'm gonna make ones that are full licenses green for good, and ones that aren't red, bad. And then I do a position, and I got this fancy function that'll open source, so you don't have to find it for yourself. And then I got a title, and I'm going to do license.name, and then snippet is another property of the marker. It's like if you click on it, it'll do that, and it'll have some more stuff. That's the snippet, put the address. How you set the marker color of the icon is, this is what you do. It's in the docs, it's just what you do. All right. Finally, I'm going to subscribe to it, and you can see on next, map add marker. That's happening on the UI thread. And for completeness, I just did it on complete and on air. And that's the app. Can I show it? Damn. Yeah. If you guys want to see it, you don't have to stick around, but I mean, it is the end of the day. This is what you've all come for.
That's right. Drink it.
Can we figure this out?
One enclosure if we don't get to see it.
Yeah. All right. I mean, a lot of demos. A lot of demos, I'm telling you.
It's fine, my screen might have to.
It was all, the emulator was running. Oh, hold on.
Genymotion
It's
doesn't
actually
support
worked.
Google Maps.
Boom, okay. There they all are. We can zoom in. Yeah.
That's awesome.
And, you know, there it is. Hey, all right. So now we just need to answer the question that we started with. If we kind of scroll in here, we can find where we are. It actually puts the University of St. Thomas right there. So our question is, where to drink? That's the closest spot, and that's where we're headed now. Let's go. Yep, thank you.
You know that Yelp has a search by